Good morning, children. So in last class, we discussed about the refractive index of the medium. So once again I define that, and again I will give some examples of refractive index values. Refractive index means the ratio between the speed of light in vacuum or air to the speed of light in a given plane of medium. That is refractive index. For different substances, different refractive indices values are there. They are different. Substances differ. Automatically refractive index also changes. See, for air, refractive index is 1. For ice, 1.3. Water, 1.33, or otherwise to write as a fraction, 4/3. Kerosene, 1.44. And glass or crown glass. In glasses, different types will be there. Here I have taken crown glass, it will be 1.52. So actually for glass I had considered 1.5. So in last class also I had done one problem in that I get the refractive index of glass is 1.5. So remember that 1.5. Or for this especially given for crown glass to add 1.52. So it's a visible value of the point. That's right. It is also treated as for glass 1.5. Okay. Then rock salt will be 1.5. Rock salt is 1.5. And benzene 1.54, carbon disulfide is 1.52, and diamond 2.42. Diamond is 2.42. See, different materials having different refractive index values. Among this, to remember, very important are air. Air refractive index is least. If compare other media, the refractive index of air is very low. It is only 1. And diamond, consider this diamond, it is the highest refractive index value. So all the materials, the highest refractive index is diamond. It's a very important value. Remember that. For this, in the next explanation, it's a very important one. Refractive index of diamond, remember, it is 2.42. That is refractive index of diamond. And main these two values are very important. Maximum and minimum. Sometimes it is also given in public examination. So write the least and highest refractive index containing materials or material mediums. Air is the least, that is 1, and diamond is the highest, that is 2.42. And another to remember this glass. Glass value is 1.5 and water. So mainly these values are very important values. Okay. This about this refractive index. So Ri, remember that Ri. To write anywhere Ri, it is a refractive index. Don't forget this. Ri means refractive index. Don't need to write complete, just to write Ri. And it is letter is, it is denoted by the letter N you have to consider here, or Greek letter you have to consider as a U. And in this refractive index is compared to one medium to other medium. You have to compare. Comparing also given for this two medium. That is called as relative refractive index. Relative refractive index, or relative refractive index. So this relative refractive index can be said to be the refractive index of the medium with respect to the another medium is said to be the relative refractive index. One medium refractive index compared with another medium refractive index. Then it is called as a relative refractive index. Or in other words to say, the ratio between the speed of light in first medium to the speed of light in the second medium is also considered as the relative refractive index. So like that also can define. So the refractive index with respect to refractive index of the medium with respect to the another medium is also said to be the relative refractive index. Or otherwise, the velocity of light or the speed of light in first medium, the ratio between the speed of light in first medium to the speed of light in the second medium is also said to be the relative refractive index. From the speeds you have to compare the relation between them. Okay. So relative refractive index, or I will write, where R is relative, another R is refractive, I is index. So relative refractive index or Ri is equal to speed of light in first medium. Speed of light in first medium by speed of light of light in second medium. Second medium, like we also had to consider the ratio between speed of light in first medium to the speed of light in second medium is also said to be the relative refractive index. So according to this, we have write as speed of light in first medium is considered as V1 and second medium is considered as V2. So relative refractive index is V1 by V2. But we know that V is equal to, remember it's a very, very important formula, V is equal to nu lambda. What is this formula? Velocity of sound or velocity of light here to consider. V is equal to, what is this letter? Nu, frequency of radiation, and lambda, the product of this frequency and wavelength gives this, what is this? Velocity. Okay? So, we need to consider V is equal to nu lambda. Here I consider refractive index formula. Refractive index N is equal to C by V. N is equal to C by V. So in that, to make V as a subject, what do you get in this equation? In this you can get V is a subject. V is equal to C by N you get. V, to make V here subject, V is equal to C by N, where C value is constant, and here V1, V2, two values to be considered. For this first medium velocity is taken as V1, C is constant by N1. So V1 is equal to C by N1. Similarly, V2 is equal to C by N2. So remember this. Refractive index is given by the formula, this one. N is equal to, so this formula is very important one. N is equal to C by V. Speed of light in vacuum by speed of light in given medium. So in this given medium to make subject V, then you get C by N. It is actual formula. In that, two velocities are to consider, two different media are to consider, V1 and V2. So there, V1 is taken as C by N1 and V2 is taken as C by N2. Now substitute instead of V1 by V2. So here to substitute, V1 means C is constant here, C by N1 by C by N2. C by N1 by C by N2. Okay. Now here, two fractions will be there. So two fractions will be there means to write as C by N1 first fraction by N2 by C. N2 by C. Here C gets cancelled. Now what it remains? It becomes N2 by N1. N2 by N1. This is the relative refractive index. Refractive index of the first medium with respect to the second medium. It is given by N2 by N1. N2 by N1. Relative index of the second medium with respect to the first medium. So it is given as N2 by N1. This can also be to write as, this place I write as, relative refractive index is there, no? It is the numerator and it is the denominator. Instead of that, to write as N21. N21, it is not N21. Second medium with respect to the first medium. Second medium with respect to the first medium means that is equal to N2 by N1. Write like that. Or otherwise, this can also be to write as N21. That is also right. N21. It can also mean the same meaning. Or otherwise, instead of to write its medium name, that means glass water or glass A to be considered, to write as, so glass means G, N, G, A. So relative refractive index of glass with respect to A, to write as N, G, A. Means to write this one, or otherwise just like to write as G, N, G, A. Like it also happened. Understand? Whatever that, numerator what will be there, first to write that medium, and next to write denominator medium. So it is not combined to read as 21. It is not a 21. It read as second medium with respect to first medium. Understand? Otherwise, first medium with respect to second medium will be given for some cases. In that cases, to write as, suppose refractive index of the first medium with respect to second medium is given. In that case, to write as N12. To write as N12 means, what is the fraction here? N1 by N2 to write. or otherwise NAG will be given. A with respect to glass, this means, that means this to write as refractive index of A with respect to glass, like that also to be indicated. So this is the relative refractive index. So relative refractive index can be defined as the ratio between the speed of light in first medium to the speed of light in second medium is considered as the relative refractive index. So by that verification you get that N2 by N1. From this we have concluded that, so according to write like this, N2 by N1 means refractive index of the second medium with respect to the first medium is also called as relative refractive index. This ratio we have to write like that. Understand? So for example, sometimes it will be given as 9 by 8 is the relative refractive, that is refractive index of the given value. A with compared with the glass is 9 by 8. Then what is the refractive index of glass with A? Fraction to reverse, that is 8 by 9. Okay. So in this manner we have to calculate this relative refractive index. Then next, loss of refraction. So already we discussed this loss of reflection. Reflection loss, you know. Similarly, refraction also having loss. So here two loss of refraction will be there. Loss of refraction. So this loss of refraction is said to be first law and second law. First law and second law. First law is similar to reflection law. So what the reflection law is given? That law is same. What is that here? Incident ray, plane of incident, refracted angle, all will be lies on the same plane. So same reflection also we have that same definition. Incident angle, incident ray, reflected ray. There we have to say reflected. Here refracted ray. All will be lies on the same plane. They are all in the same plane. That is first law of reflection. So incident ray, point of incident, refracted ray, normal, they are all lies on the same plane. Means we consider, so we consider this as the incident point O, this is the normal line O, N, N dash, and this is the incident ray. This incident ray, it will be refracted here. So it comes and moves here. This is the first medium, this is the second medium. Now here to observe this incident ray, and this point of incident O, and this normal line, all will be lies on the same plane. All will be lies on the same plane. That is the first law of refraction. That is the first law of refraction. And second law of refraction is a very, very important. The second law of refraction is also known as Snell's law. It is also called as Snell's law. Remember that, Snell's law. So here, the ratio between the sine of incident angle to the sine of refracted angle. Here to consider incident angle and refracted angles. Here compared with sine. Sine is the trigonometrical ratio. So in this part of sines, we can consider trigonometrical ratios also. Understand? Here main sine, you know that in mathematics sine, cos, tan. Main is 3. And for their reciprocals, the remaining 3 will we get. Yes, in that we consider the sine ratios here. So sine of incident angle to the sine of refracted angle is considered as a second law of refraction. Second law of refraction, or otherwise Snell's law. So once again I repeat, very states Snell's law. Sometimes will be given, or state second law of refraction. Whatever question will be asked, answer will be same. What is that? The ratio between the sine of incident angle and the sine of refracted angle is constant. The ratio between the sine of incident angle and the sine of refracted angle is constant. So that is given by that constant is, it is equal to refractive index n. So n is equal to sin I by sin r. N is equal to sin I by sin r. So the ratio between, once again I repeat this now, the ratio between the sine of incident angle to the Sine of refracted angle is constant. Here the constant is equal to the refractive index, that is n. So n is equal to sin I by sin naught. It's a very very important formula. This is called as Snell's law also. The second law of refraction, or otherwise it is called as Snell's law. So whatever the question given, answer will be the same. What is that? The ratio between the sine of incident angle to the sine of refracted angle is constant. Here sine is taken as the trigonometrical. So in trigonometry you have to consider 6 ratios will be there. Among that main you have to use sine, cos, tan. Okay. So in this sine angle, I is incident angle, or is refracted angle. So sin I by sin r is constant. Here that constant value will be equal to n, that is refractive index value. So this can be proved experimentally also. We can prove this thing by experimentation. That experiment I will continue next class.